All right, so this is going to be the day 2 lecture for test 4 for college algebra. We have graph 2x equals 3y plus 1. This is not in y equals mx plus b form. This is also not in standard form or general form. In fact, neither one of these up here are. So one of the things that you can always do when graphing, we talked about slope-intercept form using the slope and the y-intercept. We talk about standard form and general form and using x and y-intercepts and how those are the best way to graph. Well, here, there's not really a best way because it's not really one of those forms. Now, you could do some finagling and move stuff around and get it into one of those forms, or you could work with the problem in the form it's in. And so we're going to do something called a T-chart. And the reason it's called a T-chart is because you have this line here and this here, and that looks like a T. All right? Just like a T-shirt, it's called a T-shirt because it's shaped like a T. All right? So it's not called an M shirt or a Q shirt or R shirt. It's a T-shirt. Okay? That's why it's called a T-shirt. All right? So then X, Y, we have, and notice I have a spot here, and a spot here. I got 3 spots, okay? Normally, we only use 2 points to graph a line, okay? We usually only use 2 points to graph a line. When you use a T-chart, it's kind of customary or standard to find a third point because I didn't say you, I said we, that includes me. We like to make careless mistakes, okay? And so when we make careless mistakes, it's always good to check it with a third point so that if we get 2 points and then check it with a third point, if it makes a triangle, then it's not a line. If it lies on the same line, then we feel pretty good about the fact that our line is correct. So we typically find a third point. So on a T-chart, you can either pick something for X or something for Y. It doesn't have to be 0. I'm just circling it there. Okay? So if you pick something for X, what do you want to pick for X? 2? All right, so let's pick X as 2. All right? I don't remember what we picked in the first class, but doesn't matter. We picked 2 for X. So if I let X equal 2, then I'm going to come out here and say 2 times 2 equals 3y plus 1, right? Because if I plug 2 in for X, I'm plugging that 2 in right there, right? So what is 2 times 2? So 4 equals, and now it's just basic solve it, right? I mean, if you can't solve this, it's going to be a long semester, right? You can solve this. So, and there's no magic to what number we pick. Somebody just yelled out 2, and I took 2. And look at that. Y equals 1. You think every time you do it, it's going to be a nice, neat whole number like that? No. So 2, 1. Where's the point 2, 1? All right. Over which way? To the right 2 and the 1 where they intersect right there. So we have the point 2, 1. I did that in red. So now let's find another point. This time, just to mix it up, and you don't have to do this. You can pick 3 different X's or 3 different Y's. But just to mix it up, let's let Y be something. Y'all pick something for Y. 4. Hang on. Let me see in my head. Will 4 work? 4. I think 4 works. Let's try 4. Okay. So the thing, and the reason I say will it work, you can plug any number in. It's whether or not it'll fit on my grid. Okay. It's whether or not it'll fit on my grid. 3 probably works better than 4 because the fractions. But so then if I plug 4 in here, right, I'm going to take this 4 and plug it in for Y. So we have 2x equals 3 times 4 plus 1. So 2x equals 12 plus 1. 2x equals what? 13, and we divide both sides by 2. So this time we get 13 halves. How many times does 2 go into 13? 6 and what? And a half, right? So 6, I have 7 on my grid, so 6 and a half fits. So if I go here, I have 13 halves, which you said was 6 and a half. So on the x-axis, I go out to 6 and a half and go up to what? 4. So right there. So now I have enough information to graph a line, but again, it's customary or standard, all right, for us to choose a third point, okay? So let me just ask you this. What if my third point was right here? Do I have a line? No, look, I have a triangle if my third point's right there, right? That's no good. So I don't want my line point to be there. I want it to be somewhere here, right? Somewhere in this area here. So if I were to pick another value, I say pick an X value and don't pick it at near 2 or near 6 over here because we already have those. So maybe at 0 or -1 or -2 or something like that. So just pick it further away. Just to give yourself a good, because if you pick it at 1, you're so close here, that may or may not look like it's on the line. It's going to be a fraction possibly, that kind of thing. So what do you want to pick for x? -2. What were you going to ask there for?
Now, why is this point right here off in the end, like in the middle of?
Oh, because it's 13 halves. It's 6.5. So I had to go in between 6 and 7 to get that 6.5 right there, right? And that's why it's not on a point there. And that's what you get sometimes when you do this T-chart. It's not going to always be a nice, neat, integer, whole number type thing where it's at 3 or -2 or 7. It might be 13 halves. In fact, in the first class today, we got 1/3, we got 5/3, we got -4/3. We got all these different numbers, and fractions, and positive and negative that we had to go find. All right. So the key there was get in the right place. I think we even got 11/5 at one point. So here, if I let x equal -2, if I let x equal -2, I'm going to take this and plug it in for x. So that's going to be 2 times -2 equals 3y plus 1. What is 2 times -2? Equals 3y plus 1. And what do I do now? Subtract 1. I get -5 equals what? Here comes your fraction right here. You just about can't avoid them on these. -5/3 equals y. So that means if I let x equal -2, then y is equal to -5/3. So x is -2. That's this line right here. Y is -5/3. Where's -5/3? What's that between? How many times will 3 go into 5? 1 with 2 left over, right? So it's between what? 1 and... So it's between, in this case, it's between -1 and -2. Is it closer to -1 or -2? -2, right? The 2/3 left over is closer to the other one. So it's at -2 on the x, that's this one, and it's -5/3, which is somewhere in here, right? So it's going to be right about here maybe. And does that look like it's a straight line? The brown point, the red point, and the blue point. Looks pretty good, doesn't it? And so... watch this. I'm going to draw a perfectly straight line. All right. Look at that. Look at that. That's impressive there. That's impressive, okay? I cheated and used the straight line tool on the thing, right? So if I could freehand a line that straight, I'd be an artist. All right? And then put arrows on the end of my line. So that's using a T-chart.
When you graph the one that's at the top.
Yep. Like blue?
Yes, sir. Which problem was the blue up there?
The blue, yes. So I got 13 halves for the x, which is 6.5, right? So I had to come out here to 6.5, and I also had to go to 4 on the y-axis. So it's where those two things meet there. Right, when I'm plotting my point. So I'm just plotting the point that matches. This is like an ordered pair, 13 halves, comma 4, right?
You will have to convert it first because it is a fraction.
Yeah, I'd have to figure out where is it. It's between 6 and 7. That's right. That's right. I need to know that first. And so you can punch out in your calculator and get a decimal, or you can kind of figure out where it might be. Yep, and so the same thing here. I had to figure out this was between -1 and -2, right? But closer to -2. That's right. All right, so let's do the same thing on the one on the right over here. So what do you want to let x or y be something? Which one? X, and let it be what? 3. Let x be 3. Or 2. I heard 3 first, so I'll do 3. So 5y equals 2 times 3 minus 3. Right? So 5y equals what? So 5y equals, and divide by 5, and we get what? 3/5. Where's 3/5 between what and what? Between 0 and, which one is it closer to? It's just barely closer to 1, right? It's just a little bit bigger than a half, right? It's a little bit bigger than a half. So we come over here to 3 on the x, and then we go a little bit bigger than a half. And look, here's the thing about T-charts. I'm sitting here thinking back to my class at 8 this morning. I don't know that we've done 4 points already, and I think we might have done the 0.21. That might be the only point we used in the first class that we used in here. So my point is, you could all have different points that you pick. Now, they need to be on the grid. So like somebody earlier today, I think, said let y be 7 or something. Well, if we let y equal 7, 7 for the y is on there, but the x ends up being something like 8 or 11 or something, and it's off the grid, so I don't need to pick that one. I need to keep stuff on my grid, so I may have to repick, a different point. Anything for x or y. And look, quite frankly, I might want to pick 0. 0 sounds like a good thing for me to pick. So if I do that, why don't we just pick 0 for x? If I pick 0 for x, now I get what? 5y equals 2 times 0 minus 3. And what is 2 times 0? So this is 5y equals what? And then we get 5 equals, so y equals negative 3 fifths. Now that's kind of like an S, but that's a 5. Okay. So 0, negative 3 fifths. So we got a positive 3 fifths and now a negative 3 fifths, which that means it's going to be between 0 and negative 1 and just a little bit lower than negative 1/2. So here, about right here, negative 3 fifths right in there somewhere. And then finally, let's find one more point just to make sure. So you want to let x be something or y be something? Let y be what? All right, so we have 3 fifths and negative 3 fifths, so I would kind of want to go further away. 2's probably okay because that's 1.5 away. Like you wouldn't want to pick 1 because 3 fifths and 1 are really close together, right? So it may or may not work out well. So if we let y equal 2, that's going to give me what? 5 times 2 equals 2x minus 3, is that right? And what is 5 times 2? 10 equals... Yep. Hey, there it is again, Ford. Oh, that's awful. Left-hand conniption fit. Sorry. We're getting low on the board. It's harder for the offhand to write. And then we divide by what? 2. So then where is 13 halves? Like what is that between what and what? 6 and 7, right? It's 6.5 again. We saw it earlier, so we're kind of familiar with it. But 2 goes into 13 6 times with 1 left over, 6.5. So for the x, it's 6.5 again. And we saw that over here, right? 6.5 was right there. Well, that's not where it was. It was right in between 6 and 7. So over here, it's going to be the same place, and I go up how many units there? 2, right? Do I have a line there or a triangle with my 3 points? A line. Got a nice line there, right? So let's come in here and that's not what I wanted to do. All right, let's try this again, okay? Oh, the joys of technology, right? And it's a little off, so I'm going to rotate it just a smidgen here. There we go. That's a little better. And then put my arrows on the end of my line, right? We always want to have arrows on the end of our line. We don't ever want to have a line without arrows. Yes.
This is the problem that I'm having.
Uh-huh.
When we do solve the equation, I find the x, but it's kind of difficult for me because I'm seeing the fraction. Like the negative 3 over 5, where would that fall up in between?
So you would just, what I would do is punch it in my calculator and you get 0.6 or negative 0.6. And then you say, okay, that's between 0 and 1. That's about a half, right? And so that's what I did. I kind of just said, okay, it's a little bit bigger than a half or a little bit less than negative 1/2, that kind of thing. So, and I mean, again, these things are so microscopic, whether you have 1/4 or 1/3, you're not going to be able to place those perfectly, right? So T-charts can always be done. You can always do a T-chart if you want to, right? So if I don't tell you how to graph it, you can do that. Now, this is less efficient because you're finding many points here and they're arbitrary and you're having to pick them and all that kind of stuff. So try to use what's best, but sometimes it's in a form where nothing that we know is best, so to speak. So T-chart might be a good thing to try there. All right, parallel and perpendicular lines. All right, so parallel lines have the same slope. Perpendicular lines have opposite, change the sign, reciprocal, flip it slopes. So if we look around the room, what's an example of parallel lines? The top and the bottom of the board. So provided the board is cut properly, which anybody who works in construction knows that if you build a 14 by 13 room, it might be 14 one on one end and 14 and 7/8 on the other, right? It may not quite be perfect, but you're not, somebody walks in, it's not going to tell. But you're right. The top of the board, the bottom of the board, provided it's a true rectangle or parallel. If we look at what's on the screen, since this is a video and people can't see what's in our room right now, then how about this line that runs across the top of this grid and this line right here? Those two lines are parallel, right? What about this line that runs up and down and this one? Those are parallel, and this one's also parallel to those, right? So they have the same slope. So it doesn't matter if your line does this. If the next line beside it does that and they have the same slope, then they're parallel. They don't have to be vertical or horizontal, right? So now if we did this, are these two lines parallel? No, they're not. It's when you have them the same, right? And they don't have to even be tilted that way. You could have it this way and this way. Those are parallel, right? So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. What's some examples of perpendicular lines in the room? The corner, right? The corner, well, at 3 o'clock it would be, right? But the corner, right? The top of the board and the side of the board. Or where the wall meets the wall that it adjoins, right? Because that makes a right angle in a rectangular room such as this one. All right? But this line here and this line here, right? They make that right angle. That's perpendicular. Okay, that's perpendicular. So we have, this line right here, that intersection right there, that's perpendicular right there. Okay, where they make a right angle. So it doesn't matter, the lines can look like this, and as long as they make a right angle, that's perpendicular. Okay, so I gave you the chart here, and what I'm doing with this chart is I'm giving you a slope, and I'm calling that M. Okay, so I'm telling you, hey, the slope is 2 or -5 or 2/3 or -1/4 or so on and so forth, right? So those are the slopes. Now I say, what's the parallel slope? The symbol for parallel is two vertical lines. It actually is not quite so close together, but that's what Word did when I put it in the equation editor. So it's two vertical lines. And then this upside down capital T, that's the symbol for perpendicular. Now, I need to say this. I am not aware of a math book or another teacher using this symbol here that I can remember. Now, one of my teachers may watch this and go, I did that. You don't remember that? But maybe where I got it from. I don't know. I don't remember it, okay? But math teachers, some people like to call it lazy. I like to say we're efficient. So I don't want to write the word parallel each time in slope. So I'm going to use this symbol when I want the parallel slope. I'm going to use this when I want the perpendicular slope, all right? That's more of a guesstism than it is a accepted math tradition around the country or world, all right? So if I say the slope is 2, what is the parallel slope to 2? 2. It doesn't change. Okay? What is the parallel slope to -5? What about 2/3? What about -1/4? What about 1/7? What about 0? What about -11? If you miss a parallel slope, you are literally, the reason you would miss it is because you don't remember. You are literally copying it. Here's what I have been known to do, by the way. I've been known to give you a table like this, and the stuff I just boxed is blank. So I'm giving you the slope is 2, now you fill in these two things below it, okay? I'm giving you the slope is -5, fill in the two things below it, all right? So if I do that, hopefully that'd be like some of the easiest points you ever earned in college algebra, all right? So
usually come if it's y equals usually with the x.
Yes, usually it has to be with the x. If it's y equals mx plus b, it's always times the x. All right, but here I'm not even giving you a formula. I'm just saying here's the slope. What's the parallel slope? Because we're going to use this later. Okay, so parallel slope. Literally, the only way I could get tricky with this is what if I put the parallel slope on the bottom row? Then you got to right, but don't if I ask you to fill in a table and you miss a parallel slope, you're going to be a story next semester. Okay, don't be a story next semester. All right. There was this guy. He wore Chick-fil-A stuff all the time in class. No, I'm kidding. All right, I'm just kidding. All right. So then, look. What is the perpendicular slope to 2? What is 2 really over? So when I flip it, that means reciprocal means flip it. That becomes 1/2. And if it was positive, it changes to negative. That's where I get the -1/2 from. I flip it and change the sign. Same thing here. This is over 1. So if I flip it, it becomes 1/5 and it goes from negative to positive, right? And then what about 2/3? That one's a little easier to see. 3 halves and make it negative. What about -1/4? If I flip it, it becomes 4 over what? Do I write over 1? That's just 4. And then I change it from negative to positive. 1/7, flip it, -7. I always change it from negative to positive. The only exception is the next one. What is the perpendicular to the slope 0? if you remember Vux and Hoy, what does Hoy mean? A horizontal line has what kind of slope? 0. And it's y equals a number. That's Hoy, H-O-Y. The O is actually a 0. Hoy, horizontal line, 0 slope, y equals a number. So horizontal, vertical, Vux. They're perpendicular to each other. Vertical line is x equals a number. And what's the U mean? What kind of slope? Undefined. So if you have a 0 slope, its perpendicular is undefined and vice versa. If I start with undefined slope, perpendicular is 0. So that doesn't really fit the formula of -1 over m for the slope or whatever, like opposite reciprocal. But just know 0 and undefined are perpendicular. All right. And then -11/5 to me, that's an easy one. You just flip it. 5/11 and make it what? Positive. So look, if you miss a perpendicular, I can sort of get over that. You have to do two things. They're easy things, but you got to do two things. Okay. If you miss a parallel, you'll be a story. Okay. Don't be a story. So let's use some of these. And again, I may or may not ask you to fill in a table like that, but if I do, at least don't miss the parallel. Just copy the numbers down. Okay. Use the given conditions to find the equation. Look, we did this before. We were given a point and we needed to find the slope. We were given 2 points and we had to find the slope. Here, we're given a point. This is my x1, y1. And this is my parallel to this line. The only thing about this line that I care about is what? The slope, which is -5. I don't care about the b is 4, the y. I don't care about anything but -5 there. Because now I have a slope and a point, except, wait a minute, I don't want that slope. I want what slope? Parallel. What is the parallel slope to -5? Don't do the classic. You know what the classic thing is? This is college algebra. It's got to be hard. I can't just keep -5. It's got to be harder. I'm going to make something up. Don't do that. Don't make it up. Don't make it up. All right? -5, parallel slope's -5. So that's the slope that I use, even though they're the same. That's the one I'm using. All right? So I'm going to use the formula y minus y1 equals m times x minus x1. Okay? Because what we did previously with T-charts, the only time I ever plug in for x or y that don't have a subscript or that doesn't have a subscript is when I'm looking for the other one. Like we said, let x equal 2. We found 1 for y on the first point we found. Here, I'm not going to use y equals mx plus b like many people do because that gets confusing to students. I'm going to use this formula where I'm plugging in for the subscripted values and m. Okay? So when I do that, it's y what? Y plus 7 equals, and then x minus the -2 is really what? Plus 2, right? And the reason it's plus again is because the formula has a minus, and that means change the sign of these, right? Change those signs. So then y plus 7 equals what? -5x and then minus 10. And what do I do to finish this? Because look, slope-intercept form is y equals mx plus b, right? So how do I solve this for y? Get rid of the 7, subtract 7 from both sides, right? Y equals -5x minus 17. So we're doing the same thing we did when we started this business after slope about finding equations and lines. We're given a point and we have to figure out the slope. In this case, we're given a line to get the slope from, and then we're doing parallel or perpendicular. All right? So the next one is very similar. It's x1, y1, and now we have perpendicular to this line. So what is my slope of this line right here? The slope of this line is actually what? 1/3, right? But I don't want the slope. I want the what kind of slope? Perpendicular. So I'm going to do my perpendicular slope, and it's going to be what? -3. Correct. And which one do I use? -3, right? So use that one. So I'm going to use the same formula. And remember, at Northwest, can we have formulas given to us on any test in any class? Nope. So that means this is another formula. That's why I'm writing it down every time I work one. In class, in homework, my math lab, whatever. Every time. So y minus what? Which is 2, right? Y minus 2 equals, what is m? The one that I use is -3, right? Well, I use the perpendicular one, right? M itself I have labeled as 1/3, but I use the M perpendicular, right? Because I'm looking for perpendicular to that line. So again, the only thing about this line I cared about was the 1/3, but then to do perpendicular, I had to flip it and change the sign. So -3 and then X what? Why is it +4? Because it's a negative and a negative. It's minus a negative. And now I do the same thing. I distribute to -3 and then move the -2. So if I distribute to -3, that gives me y minus 2 equals what? Uh-oh.
-3x.
There you go. Don't forget that -3x minus 12. All right. And so y equals -3x minus 10. That's it. Yep. So again, the theory is the same. We need a point, we need a slope. Just the way we find our slope has been different on some of these problems, right? These two were different than the ones we did, last time we met. So we're still finding point and slope, and then using that, we just may find the slope differently. So try to remember that as you work through these. Hey, I'm doing the same thing. It's just the way I find the slope may be different. I may use the slope formula. I may do parallel to this line, perpendicular, whatever. So here, through 4, -6, so that's my x1, y1. And then parallel to the line y equals negative. What kind of line is y equals -7? What are those two? Why? So hoi, right? Horizontal. So if it's y equals a number, that tells me it's hoi, which means the slope is 0, and it's what kind of line? Horizontal. So y equals a number is this way. The y-axis is vertical, but y equals a number is horizontal. Okay? So if I want to be parallel to that, what kind of line am I going to end up with? If I have a horizontal line, what kind of line is parallel to a horizontal? Horizontal, right? So that means it's also going to be hoi. It's going to be y equals. So somebody tell me, what is the equation of the line? Yeah, that's got an x in it, right? Mx plus b. So I don't need all that on this one. What point does it go through? No, what point does it go through? It goes through what point? Aha, so what does it got to be? Y equals what? The y value is what? -6. It's just y equals -6. Because this is the y value it has to go through, so for it to be a line y equals that goes through that, it's got to be y equals that number. So we didn't need the whole formula here. I guess you could have plugged it in, but when you get an undefined slope, that makes it more complicated to plug it in. You need to remember y equals is horizontal, x equals is vertical. So if I have a y equals line and I want to be parallel, I got to stay at y equals, and it's got to be y equals whatever the y value is of the point you go through. What about the next one? So this is x1, y1, and it's perpendicular to hoi. What kind of line is perpendicular to hoi? Vux, right? And that means what? Instead of y equals, it's x equals. So it's x equals what? -3, right? X equals -3. So it's x equals the x value there. You didn't have to worry about m, or you didn't have to worry about anything else. It was undefined slope. It's just x equals a number. And there it is. I mean, I didn't really give it to you, but it's right there in front of you, right? It's almost hard because it's so easy. I mean, really.
So if it's not an equation, it's going to be just y or x.
Well, it's still an equation. Why is it what means something's an equation that has what in it? Equal sign, right? So if it's got this in it, it's in an equation. It just doesn't look the same because it doesn't have both x and y. If it only has y or only has x, only has y as horizontal, and only has x as what? Vertical. And so that's the difference on these. They're still equations. They're still lines. It's just they don't have both y and x in them. They just have y or just have x. So that's what's the special part of these. All right. So let's change the page, and I think the next page is going to be what? Distance and midpoint. So guess what? There's a formula for distance and a formula for midpoint. Yay for us. I don't know. So look. So the distance formula is literally, if I have 2 points, if I have let's come over here. If I have a point here that is x2, y2, and a point down here that is x1, y1, okay, then there is some distance. There is some distance between the two, right? We'll call it d. So this comes from, look, what if I take this distance and this one? That makes a right triangle, right? So the distance here vertically, that's on the y-axis. So what that is y2 minus y1, right? And over here, what is this distance here across the? This is x2 minus x1. In which order you put it in doesn't matter. I mean, x1 minus x2, x2 minus x1. This is actually a forgiving formula, unlike some of the other ones. Well, guess what? If we have a right triangle, y'all remember something called the Pythagorean theorem? Where you add up the two sides squared and that equals the hypotenuse squared. That's where this comes from. If you get d squared equals this squared plus this squared, then we use the square root property. We don't take the square root of both sides. That's not the square root property. We say d equals the plus or minus the square root. Well, guess what? D is a distance. It's the length of something. Distances are either positive or zero, right? If we say how far is it from here to Water Valley, is it negative 20 miles? What do? Get in our car and go in reverse the whole way? Right? It's still not negative. You're still going 20 miles, right? So distances are positive or zero. How far are you from yourself? Zero, right? You're at the same place yourself is all the time, whether you like it or not, okay? So how far are you from Northwest? You're nowhere from Northwest. You're here right now, right? So distances can be zero or positive. So that's where the distance formula comes from, is the Pythagorean theorem, okay? It comes from that. You need to know it. We're going to write it every time we do one. And then the midpoint, look, it's basically, this is take the average of the x's and take the average of the y's. Just like if you had two tests, and I said, what's your test average? What would you do? Add them both up and divide by what? 2. That's right. That's what you would do when you talk about test average. Now, granted, if you've had statistics, you know there's different kinds of averages, and we're talking about the mean there, but that's okay. We're just adding them up and dividing by 2. So that's all the midpoint is. Add up the x's, divide by 2. Add up the y's, divide by 2. And look, a lot of books have like a XM and YM, and they go out to the side and say what they are. I just put them in my ordered pair here and just said what they were. So let's go find the distance and the midpoint for these 2 points right here. So let's call this, hang on. Let's call this x1, y1, and x2, y2, right? So if I do that, my distance formula, I'm going to write the formula down every time I do it so that when the test comes around, I know it. And because I'm such a good student and I love math so much, over spring break, I'm going to write them down every day too. So, yeah, every day. Look, I'm going to tell you something. Y'all, ain't nobody in here going to look at stuff over spring. Don't even lie to me and tell me you are, all right? Like 2 of y'all might, like maybe 3. And, you know, so, you know. But it ain't anybody going to look at math over spring. All right. I mean, look, I say spend a few minutes every day. If you just spent 4 or 5 minutes writing your formulas every day, there's no way you'd forget them on the test. Because if you forget the formula on the test, guess what you're not going to get right? Any of the problems that involve the formulas, right? I mean, you know, there's an infinite number of numbers out there. You can guess and still be wrong a lot. So here, the distance is going to equal, now the way I have it labeled is going to be what? X2 is what? 1 minus 2 squared plus 3, and then why is it plus 6? Minus a negative, right? And I extended that out past the radical on purpose. What happens if you leave it like that? I'm going to blow your paper up, okay? Because your radical needs to go over everything that goes over it, okay? And I know there's probably been 30,000 points this semester counted off at 1 point apiece for your fraction line not being long enough, okay? So anyway, you know I'll do it. So make sure your radical goes. Now don't be crazy and do that for me. That's a little overkill, all right? A little overkill, but make sure you go for it. No. And so here, d equals the square root of, and then what is 1 minus 2? And that -1 must be in parentheses. There is no other correct way to do that. None. I can't do it another way. The president, the pope, nobody can. I'm the same standard you are. That's got to be in parentheses. Now, if it's a positive one, it doesn't have to be, but negative's got to be. Plus, what is 3 plus 6? So those parentheses around the 9 are negotiable. You can put those or not. But the -1, not so. So then that's going to be the distance is what? The square root of 1 plus 81. That's D is equal to what? Square root of 82, right? Oh, one. Don't forget that 1. So look, is 82 a perfect square? Can you divide a perfect square into 82? If you divide 82 by 2, you get 41. 41 is actually prime. You can't even simplify that. That is done. So for me, this is a beautiful answer. However, let's talk about using our noggin, okay? Let's use our noggin. What is the square root of 82 real close to? 9. Why? Why is it close to 9?
Because 81.
The square root of 81 is 9. So is this going to be a little bit bigger than 9 or a little bit smaller than 9? A little bit bigger. So if you plug that in your calculator and you get 17, you need to go, wait a minute. Something ain't, don't just blindly follow your calculator over the cliff. Calculators will give you the right answer, but you got to key it in right. So if you key that in and get something other than a little bit bigger than 9, you should go, oh, wait a minute, warning light. All right? So I think, and y'all, I have so much homework I've given over the years, and I still mix things up, even from 10 years ago, and I think it's last semester. All right? So I think my math lab asked you to do 2 decimals. I don't want 2 decimals, but my math lab does. So if you plug that in, I think you get 9.06, if I'm remembering correctly from earlier today. I think it's 9.055 to be, and then something else. So I believe that rounds up to 9.06. So we'll say that's what it is. I want you to give me square root of 82. But I want you to know in your mind, that's a little bit bigger than 9. All right? Don't be telling me that's 17 or 3. All right? That's like whenever I used to give the test paper with a test question. You had this house here, and you had a 20-foot. This is a 20-foot ladder, right? And it's 4 feet from the base of the wall. How far up the wall does it reach? 23 feet. What? It's a 20-foot ladder. If it was flat against the wall, it would only go what? 20 feet up. It can't be bigger than 20, folks. If you give me a number bigger than 20, that doesn't make any sense. Please do me this favor for all your teachers you ever have in the history of your life and the future of your educational life, and even for your bosses when you have a job. If they give you a project to work on, don't take them something that doesn't even make sense. Right? I'm gonna buy a house, a $100,000 house for a 30-year loan at 7% interest. I'm gonna pay 3 cents a month. No, I will buy any house you're selling. Okay? Or I'm gonna buy a $20,000 car for 5 years, $6,000 a month. I will sell you anything. I mean, seriously. Look, a 20-foot ladder can't go 24 feet up the house, y'all. So my point is, that should be a little bit bigger than 9. Even if you don't know it's 9.06 because you're not a calculator, when you plug it in and you get 17, warning light should go off. All right? Wait a minute. It's not quite right. So here, the midpoint. So for the midpoint, I'm going to say x1 plus x2. And remember, minus signs in formulas like this mean to change the sign. A plus sign in a formula like this mean to leave the signs alone, right? Don't change them. And then this is going to be y1 plus y2 over 2. So if I have it this way, what is x1? 2 plus what? 1. And then over 2, comma. The next one's over 2, and it's what? What kind of 6? Negative 6 plus 3, and then we close our print. That's my ordered pair right there, right? What is 2 plus 1? So this is 3. That's terrible. 3 over 2 and what? Negative 3 over 2? 3 over 2 and negative 3 over 2. So look, can I simplify 3 over 2? No, you could put 1.5. Unless you introduce fractions like, look, I know there are people out there that do this. They say, well, look, find the midpoint of this one. 1/2, 3/11, and negative 5/17 and 6/13. Go on and work till Christmas on that one. Okay? If you get something like that, then what I'm about to tell you won't work. But if you're just given integers like 2 and negative 6 and 1 and 3, you're either going to get an odd number over 2, which won't simplify, or an even number over 2, which will. Now, if you introduce fractions, then it all falls apart, and it could be any kind of fraction out there, and that's fine. You can deal with that if you have it. You're supposed to, in college algebra, know how to find the common denominator, right? So you could do that. It just may take you a minute or 2 or 5 or 10. All right? So let's do the next distance and midpoint. So I'm going to call this x1, y1 and x2, y2. And again, I'm going to write my formula here. Oops, not x2 minus x2. That won't work. But you can actually mix that up, x1 minus x2. As long as you subtract the x's and subtract the y's and square them and then add them together and then take the square root, it's really forgiving in that sense. So plus y2. You can even start with x2 and then y1, which you cannot do with other formulas like the slope. And if you notice, right here, I didn't have that long enough, so then I added it on there, right, to make sure that my radical was far enough out. It always needs to go over everything. Then there's no doubt. There's no ambiguity. There's no, oh, is that really under the radical? Yes, it is. Okay? So here, if I do this, d equals what? All right, so that's in parentheses, and then that's squared, right? Plus, bless you. 1. Why is it plus 5? Because it's minus a negatives, right? 2 negatives, minus a negative. And so then negative 1 minus 3 gives me what? Negative 4. And again, that's got to be in parentheses if you're going to square it, or it is incorrect. I don't care who you are, who it is, okay? And then plus 6. That 6 is negotiable. That does or doesn't have to be. 6 squared, and that's too long, so I'm going to shorten it up a little bit. Okay. So now what is negative 4 in parentheses squared? 16 plus what? 36, and that's still under the what? Radical. I haven't done the radical yet. And so what is it? 52, you say? So this is d equals the square root of 52. Does 52 have a perfect square that divides into it? So what's the first perfect square besides 1? Not 2. Is 2 a perfect square? What do you square to get 2? Come on, what's the 4? There you go. 2 squared is 4. Does 4 go into 52? Does it? How many times? She said yes, but I don't know how many. Okay. How many times will 4 go into 52? 13. See, it's beyond your times tables you learned back in the 3rd grade, right? You had the little flashcards. 4 times 12 is 48, and you stopped. You didn't do 4 times 13. But it's 13 times 4. The reason that matters is, what is the square root of 4? 2. And the 13 is a prime number. You can't go any further with that one. So this is going to end up being d equals 2 square roots of 13 because the square root of 4 was 2, right? That's where that comes from. Now, if you wanted to evaluate this before you ever plug it in, if you've already plugged it in, don't tell me. What is it going to be a little bit bigger than? 2. Go back to right here, square root of 52. 7, because the square root of 49 is what? 7, and it's going to be a little bit bigger than that. It may be 7.1, 7.2, 7.3, but it's going to be a little bit bigger, okay? So now somebody plug it in and tell me what it is. Or square root of, if I was going to plug it in my calculator, I'd go back to square root of 52. I wouldn't even worry about, I want you to give me 2 square root of 13 for me. Simplify it that way. But then if you're doing the decimals for my math lab, go back to square root of 52. Don't even, just bypass everything else if they want it estimated. So it's 7 point what? I don't want to circle it. What do you get? 7.21, okay? 7.21. I didn't do that in my head. I remembered from 8 o'clock this morning.
What if it was d equals square root 56?
Then you would do square root of 56. And 56 is going to be 4 times 14. So it would be 2 square roots of 14.
But then you can break that 14 down.
No, 2 times 7, so there's not another perfect square in it. So you'd be done at that point. So, yeah, but you could, it might be if it was 48, right? Then you'd have 16 times 3, and it'd be 4 square roots of 3 for the square root of 48. So different ways that the radicals, break down or whatever. So that's what I want, but then for decimal approximation, just key in square root of 48, square root of 56, square root of 52, whatever it is, and get it for the My Math Lab. If it asks for that. If it doesn't, just do the exact answer. But I think this is the one that does the 2 decimal places. All right, what about the midpoint? The midpoint, again, it's going to be add the x's and divide by 2, get that average x, and also the average y, y1 plus y2 over 2. And so when I do that, what are my values I'm plugging in here? What's it going to be? 3. And 3 and negative 1. Remember, a plus sign means don't change it. So 3 plus and negative 1 is really 3 minus 1 over 2. And then what about the second half of it, the y's? 1 minus 5? Or minus 5 plus 1? If I do it in the same order, but it doesn't matter. Same thing. So what's that going to be? What is 3 minus 1? 2 over 2, comma what? Negative 4 because one's positive, one's negative, right? So we're subtracting those two. That's a terrible parenthesis. All right. And so then, does this simplify now? To what?
1 and negative 2.
Now look, I want you to understand those two things simplify independent of each other. So just because I got 2 a while ago that didn't and 2 that did here, you could get the x could simplify to 2 and the other one could stay 3/2, right? So they're independent of each other. It doesn't have to both do one thing or both do the other. And look, it's also possible, you know where we got square root of 52 here? What if I'm bebopping along in this problem and I get the square root of 81? Well, that's nice. That's just 9, right? I don't have to, so it can be something simple where the distance is actually a whole number or whatever. All right? It doesn't have to be the square root of 52 or the square root of 82 or something like that. All right? So that does it for distance and midpoint. Now we're going to go to circles. And so in math, anytime we have parentheses, like we saw in the distance formula, right? The distance formula had parentheses in it. And right here in parentheses, we have a minus sign, right? Is this right here, this x1 plus x2, is it in parentheses by itself? It's in a bigger set of parentheses denoting a point, but it's not in parentheses, so there's a plus. In math, that is not always the case, but that is very common. If you have something in parentheses to a power, in parentheses times something, or in parentheses whatever, it's a minus sign, and it means change the sign of whatever second. If it's not in parentheses, it's typically a plus. And so one of the things that in circles, I don't have it up here on the board, but there's also another form of a circle that looks something like this. And if I don't have it right, don't write me, an email from my YouTube watchers or whatever. X minus h squared plus k or something like that. So notice in the parentheses, the h is minus, right? And then the k is a plus outside because it's not in parentheses, okay? That's a very common thing in math. Again, not always the case, but very, very common, okay? Just wanted to point that out to you. So if you look at some sort of transformations or if you look at shifting graphs, left or right or up or down, in parentheses is actually left and right, and it's opposite because of the minus sign, and then up and down is just plus or minus, and it goes with the number because it's not in parentheses and it's not opposite. It's a plus. So that's what the thing I had written down over here. Let me see if I can. This means go right h units if it's negative, left if it's or opposite. So h is the opposite of that. And then here go up or down depending on what it is. So I may have said that just wrong, but let me go ahead and erase that. Standard form of a circle, x minus h in parentheses squared plus y minus k in parentheses squared equals r squared, where the center of the circle is hk, and the radius of the circle is r. Now remember, a circle has a center, has a point in the center, and that's not actually on the circle, right? The radius is how far every point on the circle is, and it's all the same. Right? So if you were trying to draw cut out a round board for a table, you could, put a nail in the center of it or put a mark in the center of it and tie a string to it and take a pencil and tie it to the end and just bring it around. Keep it tight or taut as they call it, right? And make a circle. That's easier said than done, right? Last time I tried it, the rope wrapped around the string wrapped around my pencil, and I ended up, a quarter inch off, and I came back around to the other side. So it didn't work as well as I'd hoped. All right? So, but that's what the radius is. The radius means every point on the circle is the same distance from the center. So here, and then we have the general form, x squared plus y squared, and then the reason this is dx, ey, and f is because there's really like an a and then a bxy and then a cy squared there for general, I forget conics or whatever they're called there for those things. But with circles, the x squared and the y squared have to be ones, and there's no xy term for it to be a circle. All right. So here, x minus 4 in parentheses squared plus y plus 7 in parentheses squared equals 9. What is h, what is k, and then what is r squared? H is 4, and it's very good. My formula has a minus, which means when I extract h, I have to change that negative 4 to what? Positive 4. What kind of k? What is k here? Negative 7. And then what is r squared? R squared is exactly what's out here. That's r squared right there. That's 9. So if r squared is 9, what is r? 3. And again, I'm only taking the square root. I'm really using the square root property with a plus or minus, but the radius is a distance. And distances, we said, are not negative. So I don't need to worry about plus or minus. I only take the possible or positive or principal root. Okay? The square root of 9 is simply 3. So now, what is the center of my circle? 4, negative 7. What's the radius? 3. It's really that simple. Once you get 8, if you remember to change the signs of h and k, you're good. And then take the square root of r squared. So now I'm going to give you all the tricks. I gave you one straightforward. Now I'm going to give you all the ways I could trick you with fractions, with radicals, with things that aren't perfect squares. I'm trying to think of things that don't have anything after x or y. So how do I trick you, so to speak, or how does the author try to trick you? Well, if I look at the next one, what is h? We're still going to identify h, k. It's 11. What's k? What's r squared? 100 over 49. If it's one term over one term, how do you take the square root of that and get r? You just take the square root of the top, which is what? Over 7. So then what is my center of my circle? 11, 13. And what's the radius? 10 over 7. I don't like that. 10, that's not that much better, but anyway. 10 over 7. So 11, 13 is the center, and 10 over 7 is the radius. And look, we're going to use this later. We're going to say, okay, let's take this and actually graph one of these things. Now, it would be hard to graph 10 over 7 as a radius because we'd be guessing kind of right with that fraction thing. So, all right, so now here I'm really giving you some stuff. I got you some fractions up in here. I got you a square root, a radical trying to mix you up. It's the same thing. Yeah, what is h? See, don't let that throw you off. Look, know what you know and go on with it, right? What is h? Negative 1/2. What is k? Positive square root of 5, right? Just change the sign. Just don't look, I know what happened. Y'all saw that square root and you froze up. Say, what, huh? No. It's just square root of 5. And then what is r squared? So what is r? 7. So what is the center of my circle here? Negative 1/2. Don't forget that negative. Negative 1/2 square root of 5, right? Look, even though that's not like 1, 2, it's still a point. It's just not whole numbers, right? Integers. What is r? 7. And then the last couple of tricky ways that this could be done. What is h? What is k, which is a tricky part? And then r squared leads to r being a tricky part. What is h? 1. What is k?
Negative 1.
What's subtracted from the y here?
The minus.
What do you see? Y minus what? Nothing. What's the number that represents nothing? Ah, there we go. So you're not, when you don't have anything attached to x or y, then that h or k is 0. That's the quote unquote trick there. Then r squared is what? So what is r? There you go, square root of 11. Okay? We did the square root of 49 to get 7, right? The big thing is on r squared to r, don't go the wrong way. Like on the first one when you did 9, don't go to 81. Take the square root of it and get 3. Okay? So here, what is the center? 1, 0. What is r? Square root of 11. We rolling. We rolling. So h, 2 more would be good. And then this is r, right? So there's a couple different ways to do this one. Some people just plug it in and then simplify the formula, which is a little bit cumbersome because it's such a long formula. So let's start with that. The formula itself, which I'm going to write down because I'm going to write down every formula every time. X minus h in parentheses squared plus y minus k in parentheses squared. And that equals what? R squared, right? R squared. And so when I go to plug it in, this is going to be x what? Minus 9 squared plus what? And instead of minus 121 is what? Plus, because it is minus a negative. Bless you. And then we have equals 17 squared. The only thing that needs to be simplified here is the 17 squared part. So I have x, and I'm just going to go ahead and go to my answer box. X minus 9 squared plus y plus 121 squared equals what? Which is what? 17 squared is 289. Yep. I don't want you writing down the two parentheses twice and foiling them out, because that would give you a different form of your line. But I do want you to simplify the number squared, 17 squared. All right. So then, what about this next one? We got H, we got K, and we got R. So X minus H squared plus Y minus K squared equals R squared. And here's what some people like to do. Some people come over here and say, hey, R is the square root of 13. R is the square root of 13. So let me go ahead and find R squared over here so I don't have to rewrite my whole formula again. What is R squared? 13. If I square the radical, a square root, then I just drop the root, right? Square root of 13 squared is just 13. So now I can directly plug this in for R squared without having to square it later. So here, since I'm ready to do that, let's go ahead and plug this in. It's going to be what? X plus, why is it plus 5/8? Because it's minus the negative, and that's squared. Don't forget the squared. And then plus what? Y minus 2 squared, right? In parentheses, Y minus 2, and then square it. Equals what? 13, right? I went ahead and found R squared. That way I didn't have to go do that. So let's graph some circles. Let's graph some circles. This will be fun. So X minus 1 squared plus Y plus 1 squared equals 16. So I need H, K, and R again. So H, K, and R squared, and R. So H is what? 1. Right? Remember, don't forget to change the sign, right? So then what is K? Negative 1. Then what is R squared? 16. So if R squared is 16, what is R? 4, right? Right? Be sure don't do half, right? Do the square root, right? So then the square root of 16 is 4. So then my center is 1, negative 1, and my radius is 4. So the way we draw a circle whenever we're trying to graph it, is going to be to put the center first. Even though that's not on my circle, we still draw it. So it's actually going to look like a bullseye and a target. Okay? How you have a circle and then you have the bullseye in the center. That's what the center is going to look like, the bullseye of your target. So here, 1, negative 1. So 1 to the right and down 1. That's the center of my circle. Right? 1 on the X, negative 1 on the Y. And then from that point, what do? I go which way? 4. All right, so 1, 2, 3, 4, up, and what else? I go 4, which direction from the center? Right 4, and then out to the what? Left 4, that's over here, and then what? Down 4. It's much harder on a grid like this to go at a diagonal, okay? Because that's not one unit. That's more than one unit right there. So I can only go up, down, right, and left. And here I want to tell you to exaggerate your curve. I want you to exaggerate your curve because if you don't, it's going to look like a diamond. And if, I mean, should be 7. Should be 7, I hope. Exaggerate it. So what I mean is, when I start this, y'all's is only 5? Yes. Oh, okay. Does it fit on yours? Yes, it does. Okay, barely. Start straight up and come straight into the side. That's not even good enough there. Start straight out and then come straight. That's not even anywhere close. Let me get everyone to see it. And then just exaggerate your curve a little bit. That's still bad. I'm going to get this right in a minute. Yeah.
So you do want us to draw the circle?
Yes, I do. I want you to draw the circle. And look, again, if you do this, I'm going to count off if it's a diamond. All right? It can't be a diamond. It needs to be curved. Now, that's not perfect. That's far from perfect. It's kind of looks like somebody punched it a little bit and whatever. But that's close. So just get close, but not a diamond's not close. So if you'll notice, I said start like at the top, go straight out, and then come straight down on the side over here. Okay, exaggerate your curve, and then it'll look a little better. So that's how we graph that one. So let's graph some more circles. How about it? Sounds like fun, doesn't it? Because circles are so much fun. I love algebra, right? If I had $1 for every time I'd say that, I'd have less money than I do teaching. Nobody likes algebra. All right, so right here. This is my H. Well, really, it doesn't even matter because I'm given exactly what I need. Where is the center 0, negative 2?
The point origin.
So from the origin, go where? Down 2. And there's my center. And from that point, I do what? Go up 3. Then I do what? Right 3. Left 3. Uh-oh. Got an extra point there. Left 3. And then also what? Down 3. And that one also fits on your grid barely, doesn't it? If it's 5. My apologies. I meant to give you the 7 like I have here.
As it is in the original, we just go ahead and graph it.
Yep. Yeah, like it's already given. We didn't have to extract anything there like we did in the last one. It's just given. All right, so then remember, exaggerate the curve. So that's too much exaggeration. Exaggerate more. Let this be the 5th time you've told your fish story, and now it's 4 feet long instead of 4 inches long, right? All right. It's a 12-pound bass instead of a 1.5. And so again, that's not great, but that's circular-esque. Circular-esque.
And 0, negative 2 could also be X and Y.
That is X and Y, not could be, that is. So the H is the X and the K is the Y. That's right. It is a point, X, Y. It's just a specific one in the sense of circles. It's the center, the H and the K. But the H is always the X and the K is always the Y.
H is always X.
Yes, H is always the X and the K is always the Y of the center. Left 3 and up 1 for my center here. And this may, it's going to fit on your grid, I guess. And then up 2, left 2, down 2, and look, it doesn't matter. I heard some of you, I went too many, didn't I? I went down 3 there. Let me fix that. Down 2 units. All right, and then this, to me, the smaller it is, it's a little easier to do. So now I hope that my circle looks better. All right. All right, and that one actually looks pretty doggone good. Okay, it's especially for my awful handwriting. So as we get ready to turn the page here, we go to the next thing here. This is parabolas, and we will actually pick up with this on Thursday.